Hello and welcome to another Trev Talks Tech. So, did some music stuff last time. This time I'm into a different kind of project and I'm going to be taking apart some bits and pieces. I've certainly been inspired by certain other YouTubers out there and I love their stuff. And certain people are definitely after my own heart in this regard because it's something I've always loved doing. So here you go. I've already done a couple of these. You've seen the bubble gun dismantled. You've seen the bearing and mixer dismantled if you've been watching my channel. And now I've had this hanging around for a while. It's TP-Link Smartplug HS100. And it's something's happened to it. It just simply doesn't work. And I don't quite know why. There seems to be no rhyme or reason for it, but that's the thing with electronics, isn't it? One day they can be working and the next day, for no explicable reason, without going into it, it stops working. So let's actually do something about that, shall we? And take it apart and see what we can do. So I literally haven't tried to open this before. There is no rehearsal for this. So let's have a look. Now I've taken many electronic parts apart before. It used to be a job back in the day, and I've spent 40 years in the rail industry doing different kinds of things, and I'm just now looking at this and thinking, well, how do I get into this? So I've got the obligatory spudger as a tool. First time I came across something like this, someone told me to search online for a soldering aid, which is an interesting one. And when you do that, you get plastic bits and pieces like this. In fact, one of these, some version of this even came with some, let's have a look at these, some little black wheels. And they were specifically for removing the glue around 2015 iMac, of all things. So trouble is with these kind of spudgers and plastic ones, they're just a little bit too broad to get into things. So I'm just thinking now, how do I get into this? Now it doesn't work as of now, so I'm not too bothered if I end up breaking it. Ideally I'd like to get it working, and I'm wondering now if there's maybe something under the label. So I'm going to peel that off and have a look. There we go. Look, there is something. We've got a hole there. Let's just expand that out, and it should come as no surprise that yes, there is actually a small screw in there, hidden under the label, for good reason, because we don't want people, the manufacturers don't really want people poking their fingers into these things. After all, it is a mains device. Who, there's enough as it is that it can be problematic for people to start looking into mains devices. Hence, we have these phrases like "no user serviceable parts inside," and that would be true if you weren't actually if you weren't just a user, if you were actually trying to service the thing or repair it. So that screw, let's see what difference that's made. Now I think now it ought to come apart. Maybe that one screw was the thing that was holding it together. The obvious seam on this, and good God, this is tight, is between the two halves here, but I've got to say it's not really giving me the wanting to come out vibes. I wonder if it's in here. Okay, I'm thinking I may have to pause for a moment just while I try and get this apart, because it's far from obvious where some of the where this goes from now. That screw ought to do something, and oh, it's not doing anything so far, so I'll be back. Okay, the spudging part has been complete, and yes, certainly that was extremely hard to get out of there. Let's have a look at this now, if I can just get you into the camera. So this is the lid off. There is the button at the front there, complete with LEDs. Yellow and green LEDs is the one for actually activating the unit. There's also, it's just falling out again. There's also a little sort of settings control button. It's actually got the sort of settings logo. You're not going to be able to see that probably. There you go. You might just be able to see that, the settings logo on the top there. And of course inside the shell is we've still got the mechanism for the UK 13 amp plug, and this is one of the reasons we're so proud of our 13 amp plugs, because every plug contains a fuse, and the shutter mechanism makes sure you can't simply poke something into a live socket. But now all of that will pop out of here. There we go. So that's the whole thing apart now. That's the shutter mechanism. Not that was a completely gratuitous removal of that component, because it makes no difference whatsoever to what happens next. So let's have a look at what else is going on here. There's a little edge connector here on this, and all that's doing is soldering this top board directly to the bottom board. And there is, try to angle this so you might see it. I don't think I'm going to be able to manage, but yeah, you can just see in there that there is actually some glue holding this little bridge PCB in. So first I'm going to sort of see if it's strictly necessary to take that out. At some point I'm going to have to actually try to work out if there's any obvious component damage that is the reason why this stopped working. I suspect that there is a thermal fuse or something like that in this, which is the reason it just doesn't work anymore. Maybe it got a bit of a transient spike off of something it didn't like, and it's blown up its little processor, who knows. But a little bit more disassembly is required so that I can get into the bones of it, you know, right into the bowels of the thing. So let's just take this off. I'm going to have to turn on my desoldering tool recording. I'm still getting used to the Osmo. I love this camera. I think it's brilliant. It's really encouraging me. Sorry about all the zooming in and out here. It's really encouraging me to do more and hopefully better videos as well, because it's so easy to set up the camera. So personally, one of the things about me is, and some people would probably say, well, that's a surprise. Not. I'm ADHD with autism as well, so ADHD. Very hard for me to get things going sometimes and to get projects working. And because of that, anything that makes the actual job simpler is going to really help. You know, anything, the fewer obstructions I have to getting started on a project or started on a video, then the easier it gets. So this Osmo Pocket Mini 4 camera, I think I've got that right, is absolute godsend, because I can just move it around. It's easy to stand up, especially for projects like this. It focuses easily on small details, like I did a moment ago. You can see that should be in good focus. My other action camera just can't cope at that sort of level. So my desoldering gun is just heating up. I'm going to desolder that little PCB and try and get further into the bowels of the thing. I need to change the tip on this really for this job, but it's already heated now. Desoldering pump makes everything so much easier. Okay, just realised I can actually enable the active track on this to keep this device centered on the camera as well, and so that's good. Other things I'm learning is probably I should put the camera on the other side, because I tend to mask the object I'm working on with my left hand, so that's good, isn't it? Still, there we are. Okay, right, so that's the top PCB off, and now we can see a bit more of the detail of the thing. So let's have a look here. The mains is coming in on here, and clearly the relay to operate that is here. It's actually a 17 amp relay, 17 amps, 277 volts. Well, that's really good because it's rated at 13 amps, so there is a good 4 amps leeway there in terms of the relays rating. I wonder now if this will actually come out, or whether there's anything additional that has to happen. I suspect now there is actually, you can see it there. There is an edge connector which is just along there, which is holding the mains board on, and I suspect that that's probably going to be able to be levered off. I think it's a connector and not, it's soldered in the top. I wonder if it's soldered in the bottom. The thing is, it's almost impossible to tell. So a little bit more desoldering is going to be necessary here. Let's bring in the amazing desolder gun and see whether this is going to help. Let's get, I might need to flow some new solder on here to make it work. Yeah. I've got the temperature set to 380 on here. I'm just wondering if that's enough, frankly. Okay. Yeah. Bear with, I'll get that desoldered and I'll be right back. Okay, let's try that again. I've got a new bit on desoldering gun, and I've also moved the camera because I've realized that I tend more to the side. This is a new desoldering bit. Still had a little plug of solder in the front of it for me to, which comes off. Now I'm desoldering these pins because I think that I've got a suspicion that, yes, of course, they're soldered to the backboard. And if they're not, they're certainly putting up a fight. So I want to eliminate everything that might be stopping me from desoldering this board here. And tell you what, in spite of all of that, the solder connections on here are having none of it. I've actually increased the desolder gun temperature now. I'm really only just flowing some new solder on here just so as it gets some flux. What I really ought to do is buy some proper solder flux, and maybe that will be the thing to do. Just clean up around there as best I can. There's a couple of other connections up here which, if I look carefully, are actually connected to the bottom of the board as well. So let's just try to get those out. This is going to take quite a while. This is where a desoldering gun isn't quite so good, because it's very, very hard to actually get into some of those small spaces. So tell you what, I won't bore you with all of this. I'm going to switch off and come back when I've finally got this board apart. Okay, well, I don't mind telling you that was difficult. In the end, so if I just show you the guts of the thing here. Okay, so there's the thing I'm supposed to be active tracking. Yeah, there you go. So there are these two obviously riveted or molded in connections, not rivets, molded in connections here that come up from the mains pins, and they're soldered in. And what I didn't realize at first was that actually to get the whole thing out, I didn't really need to desolder that connector. All I had to do was to desolder the two pins. The earth pin actually comes straight through. None of the circuitry in here has anything to do with the earth pin in it, and that's fine because the earth goes straight through. And internally in this, well, you're not supposed to be touching it, are you? It's all plastic encased, and there shouldn't be a need for an earth pin. And what I've noticed is that the live connection here, that goes straight into, can you see here, it goes along, it actually tracks along into here, and that drops down onto this bit. That's my live, isn't it? If you think of the plug going over the top, that's the live pin. That's riveted to here. It appears to be riveted to quite a large piece of quite a large bit there for some reason. I'm surprised there's so much live mass there, to be honest. And what happens to it then is it drops onto the board underneath, and there's all sorts of, yeah, so we've got those connectors there. There's another connector, actually, yeah, sorry, the live obviously has to go through the live output, that has to go through the relay. So what am I saying? The incoming live is on there, and that goes onto a pin inside here, which goes, can you see this? Shrouded in there, there is a 2-watt 10 ohm resistor, and it says F1, so it's a fuse. So I'm going to put my money on that actually being dead, that fuse there next to the relay. That's where I'm, because literally nothing on this works. It won't even turn on. So that's obviously a prime culprit. But then of course the question becomes, well, what made it die? There's an awful lot of diodes and capacitors on here, and any one of those of course could be responsible. There's also a little, what looks like a little inductor there, not suspecting any real problems with that. So I'm going to go around and test all of the capacitors and see whether there's any problem there. And I'll definitely take this fuse out. Let's have that up now. Now it's actually, the track for it is actually on half underneath and half on top. So slightly annoying, but I'm going to have to try to get that out from the other side. There we go. Let's have a look at that. Oh, these were really handy, by the way, for trying to get this off. I was managed to lever this up. I had to reflow that joint and keep the soldering iron on it in a vise while I actually pulled this off with pliers. These pliers, these are brilliant. That finally worked. So let's have a look at this here fuse element. I can't help but imagine it's gone. I could probably test it from just there, to be honest, but I'm going to take it right out of the board so I can show it to you better. Okay, here we go. Modern solder, you have to fight it the whole way. You know, I know there's a reason why we moved away from lead solder, but to be honest, I'm not really feeling it. Oh well, there you go. It's actually come away without the leg, like some kind of weird sea creature you've tried to catch. So let's have a look at this then. It says it's 10 ohms, 2 watts. I don't know if I've got enough. I'm going to have to open that up one second. Let's just get the heat shrink off this. I could just test it like it is, to be honest, but I want to have a look. I want to have a look at what's in here. It's labelled as a fuse, like I say. My honest suspicion is that it is. It does have a problem. It's failed, I suspect, for the fact that there is zero, absolutely zero activity on this plug when you put it in. It's got to be, hasn't it? Although I must admit, I can't see any external signs of it having gone. So let's have a look inside. After everything I've said, do you think it's going to turn out that I'm actually wrong? So there you go. 10 ohm 2 watt. Let's see whether that's actually gone. So there's my fuse. Now let's just get the meter and have a look. I've got a couple of meters now. This one, I've had, the one I'm about to use here, I actually had for a very long time. And if anyone knows their products, my Cronta obviously was a Tandy brand, which tells you how long I've had this meter. And it's actually wrapped, the cable for this, but the cable, what am I saying? I'm losing my words today. The cover I keep this meter in is for an old Commodore calculator, which I had at school. So yeah, this has definitely been, this is a bit of a nostalgia trip every time I use this thing. Let's just look it down to 200 ohms. Switch it on. This should read 10 ohms if it's good. I can chase it round the flipping desk and try to hold on to it. Am I getting anything there? 15.2. Well, 15.2, given my dodgy leads and given the accuracy of these resistors, I would say that 15.2, most surprisingly, is actually reasonable. Unfortunately, what I've done now, of course, is I've more or less demolished the lead at one end. So now I've got another problem, which comes about from trying to fix this thing. Oh, I could just spend 15 quid and buy another one, but where's the fun in that? Right, let's move on and check a few other things and see if I can't put this resistor back together with a lead on the end. Okay, so here we go again. I've finally managed to get the top section off. Again, it involved a lot of reflowing of joints to do some desoldering, and in the end it was down to a little bit of brute force with these just hanging on to the board and using the leverage to push the other pin through. So there we go, it's out. And obviously you can see, we've looked at the back of this already really, but a couple of things to notice. Well, that was not just a push-in connector, it was actually soldered all the way through. So I guess that's not really a surprise. And then we've got some diodes back here and a couple of chips. Not sure if that's going to show up on there, but the reading on the number on this chip, that is very small. Looks like KOH. Just go very careful. You can see the number there. This marvelous little electronic microscope is brilliant. Big shout out to Big Clive for showing us one of these on AliExpress. It's an absolute lifesaver when you're trying to read tiny little component numbers and things. Absolutely brilliant. And yeah, and of course is great for doing things like this, because with the screen on I can show it to you too, and wow, just wow for just how much detail. And of course that's the key thing on there. There's not much else on here which I can't see. I have to say there's a lot of diodes, and on this side capacitors. Yeah, Nothing on there on this side that really I need the microscope for. But okay, so there is. That's a charming little sound when you turn it off as well. All right, so where to go with this next? I've established it's not the fuse resistor, and worse still, I've almost broken the end off of that resistor, and it's going to take a little bit of effort to recover that. I hope that's not going to be a problem. Of course, it could be the chip itself that has failed. There's no telling. So let's have a look at where this goes. Let's take a logical approach to this, shall we? So the fusible resistor actually having a track on the top is quite useful, because the next place that goes is to follow this track round, and it heads into this here diode, which is labeled M7. It's D7 on the board, but actually, wow, there's one on the other side as well. So that's then going into a small capacitor just here, and then that's feeding into the PCB. So that brings us back up onto this board. Again, there's quite a lot of electronics on this board, and in particular, I suspect this is the Wi-Fi component part of it. Let's bring up the Romper Room magic mirror again and have a look at that. Creon or CFEon. You're just about. I'm sorry if it's upside down. QH or OH16B. What is that chip, and do I really need to worry at this stage? Obviously, the shielded part would appear to be something to do with the Wi-Fi connection. I shouldn't wonder. There's a little antenna connector there, actually, J1. Let's see if I can just bring that on the screen for you. J1. Where is it? There it is. Can you see that? Well, that looks like a high frequency connector, but I have to say there's no evidence of anything like that here. What there is evidence of, mind you, if you look in the back here, is a lot of gunge. And I'm thinking, well, where could that have come from? Something, is it just grease? Is it just grease or something? It's sort of sticky. And it makes me think that maybe some component somewhere has gone. The electrolytics might do that. I think I might take the electrolytics off the board and see what they're like as well, and hopefully that will give me a little bit more insight. Of course, I don't think that's the result of me trying to desolder stuff. I think that's come about. Was already there, because it's all the way up here in the PC, where the PCB was clipped in. So yeah, God knows what's going on there. All right, let's take all these off and we'll get into it. I love desoldering with a desoldering gun. Sorry if I mentioned this before in a previous video that you may have seen, but my first job out of school was repairing the 16K add-on RAM packs for Sinclair ZX81 computers. Yes, I'm that old. And one of the fun parts of that job, and I have to say that there weren't really many, was that you got to play with a desoldering gun. That, I believe, is an inductor, and I don't want to rip that off the board if I don't have to. So let's see if one of these has gone. I don't have an ESR meter, but I do have a capacitance testing device. These two wires are for cleaning the desoldering gun. And let me just see whether positive that side. Oh, come on. In you go. Right. This wasn't the easiest way of going about things, was it? See, I don't think the leads are attached. I don't think I can do capacitance through the meter leads. I'm going to get myself an ESR meter. It's definitely worth it. 4.06. Well, that's okay. That sounds pretty reasonable, especially given the way I'm trying to test these. Come on, in you go. Right. And trouble with quick improvisation. 3.93. Oh no, 4.04. So neither of those are problematic. Let's keep trying with a few other things. Let's check these diodes out as well. Let's just check these diodes to see what I get. It's hard to see the meter in shot, I'm afraid. Sorry. There we go. Let's put the meter back on. What do we want? We want it on diode test, which is there. The two diodes are actually in opposition, so I'm not quite sure what it proves if I test each one separately. I've got the 0 through there. I've got 0.5 that way and 0 that way. Well, that's what I would expect. Well, maybe these two diodes aren't actually in parallel. Well, I thought that was a bit daft. So no conduction there. Turn it round. And 0.5. Yeah, so actually the two diodes do appear to be working as intended. So which begs the question, I think I'm getting into the realms of other components that might that I probably am very unlikely to be able to obtain easily. I'm going to try this capacitor. Looks like a wee bit suspect, so I'm going to take this one out. Let's just cut the meter out of the way. Let's take out this one here. And let's just see what it's up to. It's kind of glued in as well, which doesn't help matters. Which makes me think, have they done that because this part of the board is prone to any kind of problems like that? There's my sponge. Here we go. It's not charged up. This has been sitting here in my workshop for ages, so let's try and make sure that is definitely. I've got my iron turned up to 430. That's Celsius, so it needs to be because of the flipping modern solder. Sorry for going on about it, but I mean, seriously, couldn't we just have had? It would have been so terrible to find a solder alternative that works at a similar temperature to lead. Really? Yeah, we're clever these days. We can do these things. Oh, right, okay, that's got that one out. Of course, it may be absolutely fine. There's no, again, I can't see any evidence of any leakage on there. Don't know about you, but I can't. Just the glue. There's another little cap there. Again, none of them look particularly suspect to me. You know, there's nothing. There's really nothing, unless it comes down to one of the individual chips. I'm going to go around and check the other diodes Let's check that one capacitor as well. So none of the caps I've taken out so far really can be considered the culprits in this situation. I really don't think it's any of these. To say, I've got a couple of inductors here. Don't think it will have blown those. I suppose one thing I could do is just a quick resistance test in circuit and see whether there's anything suspicious about that. So I've got the meter on 2K range, and let's just see. Nope. Next to, well, it's hard to see if it's, I don't know if it's actually dead short, of course. I can't prove that. But I can just try it. Yeah. So both of the inductors on there, again, are actually fine as well. So the mystery deepens, really. I've been looking on the online. Good old ChatGPT is very instructive when it comes to chip numbers and things. And first of all, it said that the KO number, which is visible on there, that is actually could be proprietary. But then it started talking about the other number. I seemed to ignore that other number at first, the OB2222 MCP. That's the little chip here, and that's for creating a switching power supply. So my next suspicion, seeing that the fuse is actually intact, is that the chip itself may have failed. Now apparently they are available, so I'm going to go online and obtain one of those and fit that and see, and also get a new, I think if I'm going to order components, I'm also going to get a new fuse as well, and I will plug that in rather than try to repair the old one. And yeah, that should be the thing. So I'll be going to somewhere like AliExpress, I think, or wherever I can get them from, and I'm also probably going to invest in a little ESR meter, because it would be nice to be able to check these capacitors as well and make sure that not just their actual component value but also their series resistance value is in keeping with what it should be. So that's it so far. I will be back with another section on this as soon as the parts arrive. Okay, cheers.